Okay, so for our third example of the quadratic formula, we have y squared plus 18y plus 77. So those are some pretty big numbers. Probably going to need a calculator to do this particular problem, and that is perfectly fine. So again, it's already equal to 0, so we don't have to worry about that. We just need to pick out our a, b, and c. Our a is 1, our b is 18, and our c is 77. So again, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, making sure we get that memorized. So now let's plug this in. We've got this time y equals, since y is our variable, but it doesn't really matter. If you put an x there, that's perfectly fine. We've got negative 18 plus or minus the square root of 18 squared minus 4 times 1 times 77, all divided by 2 times 1. So you see we've got some pretty big numbers in our parentheses, or in our square root, that we have to work with, but that's okay. So we've got negative 18 plus or minus the square root. So 18 squared is actually going to give us 324. And then when we do negative 4 times 1 times 77, that is going to give us a negative 308 divided by 2. So now we need to subtract 324 minus 308. So this is going to be negative 18 plus or minus, that is going to give us the square root of 16 over 2. Just like our first one, the square root of 16 is actually a perfect square, so we actually can take that and we can say that this is negative 18 plus or minus 4 over 2. And again, the second you say that this is perfect and you can take the square root of 16, making him the number 4, we then need to make sure that we break this apart into two separate answers. So we've got negative 18 plus 4 over 2, and then we have negative 18 minus 4 over 2. So this particular one is going to give us negative 14 divided by 2, which is going to give us negative 7. So we can say that y is equal to negative 7. This one here is going to give us negative 22 divided by 2. And that's going to give us negative 11. So we would say that y is equal to negative 11. And these would be our two distinct answers. Okay, so let's look at number 4. Hopefully you notice that number 4 is not equal to 0. We have this 11x and this positive 6, and both of those need to be moved over to the other side. I'm going to start by moving the minus 11x, or the 11x, by minusing him from both sides. So that is going to give us 3x squared minus 4x equal to 6. Now we need to move that 6 over, so we're going to subtract 6 from both sides. By the way, I'm doing this in two separate steps. If you'd like to do it in one, that is perfectly fine. So we're going to have 3x squared minus 4x minus 6 equal to 0. So now that we're equal to 0, we can use our quadratic formula, picking out our a, which is a positive 3, our b, which is a negative 4, and our c, which is a negative 6. Again, we can write our quadratic formula over here. We've got x equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now let's plug this in. Now one of the things I want you to notice about this problem is, notice our formula again is that negative b, or opposite b. Well, opposite of our b in this instant, because our b is a negative 4, would be a positive 4. So we would have 4 plus or minus the square root. Then we're going to do our b squared. Again, our b is -4, so we're going to do -4 squared. Notice that I put that in parentheses because I want to make sure you understand that when we square this, we are doing a -4 times a -4 minus 4 times a, which is 3, c, which is -6, all over 2 times a again, which is 3. So now we're on to our simplification. So we still have our +4 there, plus or minus the square root. Again, this right here is -4 times a -4, which is a +16. Now let's look at our signs here. Notice that you have a -4 times a positive times a negative. So two negatives multiplied together here is actually going to make that a positive. And then you can worry about the fact that you're multiplying 4 times 3 times 6. 4 times 3 times 6 would give us 72 over 6. Now we can add together our 16 and our 72. So this is going to equal 4 plus or minus the square root of 88 over 6. So we cannot take the square root of 88, so we do have to break that down. So we're going to have to break it down to 8 and 11. 11 is a prime number, so this is going to break down to 4 and 2. This is going to break down to 2 and 2. Now remember, we're only looking for pairs, and we're going to cross out the 4, the 8, and the 11. So we do in fact have a pair of 2's, so that is going to come out here in front of our square root. But we also have, oops, I didn't mean to cross out that 11. I'm sorry. That is a prime number. We don't want to cross him out. He is one of our terminating ends. So we do have a 2 and 11 that are right there together. We need to multiply those back together. So this is going to end up being, I'm going to come up over here. This is going to end up being 4 plus or minus 2 square roots of 22 over 6. Now again, look at the numbers here. You have a 4, a 6, and a 2. All three of these numbers are divisible by 2. So we are actually going to divide out a 2 from all three of these numbers. Now when we do this, notice I didn't talk about the 22 underneath the radical. You're never going to talk about him. You're only going to talk about these outside numbers. Okay? And they all have to be divisible by the same exact thing. So this is going to give us 2 plus or minus the square root of 22 divided by 6. Nope, excuse me, that was wrong. Divided by 3. And there is our answers. And remember, there are two distinct answers right there. One of them is 2 plus the square root of 22 over 3. The other one is 2 minus the square root of 22 over 3.